We are starting this with this session. Welcome to our webinar on OWASP ML Top 10 Addressing Critical Risk in Machine Learning. We have a special guest from IIT Kanpur and IIT Hyderabad. So let give me a brief about KALIIO Community. So we have started this community for student and technology enthusiasts for our various domains. So KALIIO Solutions, a platform which designs and develops web application and Android application. We have our clients from various domains. In this session, we are going to explore about OWASP's top 10 vulnerabilities in machine learning. I would like to introduce our special guest. Please welcome Sagar Bhure. He has two patents. He also is a project lead at OWASP ML Top 10 and a Blackhat speaker. He has completed his graduation from IIT Kanpur. So welcome Sagar. And our second guest, Mr. M.S. Nishanath. He is a software engineer and alumni of IIT Hyderabad. So welcome to M.S. Nishanath. Sagar, you can take over this session from now.
Yep, I still see the welcome to Kali community slide. I mean, is it same for you also?
Okay, no, just wait. I think there is a little bit internet issue. Just a second.
Nishan, do you also see the same?
Oh yeah,
Yes.
yeah. Is it correct now?
Yeah, it's correct. Yeah, so you can go to the
Yeah.
next slide.
Yeah. So our today's session, yeah.
Yeah, so probably I'll take it over from here. Thank you, Prasad,
Yeah, sure.
for the warm welcome. Yeah, so my name is Sagar, and I have been into machine learning and the industry from quite some time now. And this slide will actually talk about what OWASP is and what top 10 means and what machine learning security top 10 is all about. So for those who may not be familiar with what OWASP is, it's also known as the Open Web Application Security Project. It's an online community dedicated to providing freely accessible resources in the areas of IoT, system software, and web application security, and a lot more than that, including blockchain, quantum, and all those things, right? For related to all the software secure development lifecycle of any software development. Their flagship list of top 10 security risks is widely used by organizations to secure their software development lifecycle. So you have a list of top 10, and when any organization develop their product, or when you buy something from any organization, you check that, hey, is it secure from all the top 10 list that is mentioned on the OWASP website. So the first thing for those who are not familiar with what OWASP is, to probably head on to our website on owasp.org and start exploring that, right? Now, with understanding of OWASP and its top 10, let's delve into the securing machine learning deployments. So all of you might have used what ChatGPT is, right, by now, or let's say the facial recognition technology that is used to unlock your mobile devices. So we face a comprehensive array of the top 10 attack vectors targeting to machine learning deployments. Probably how I can hack facial recognition, mobile facial recognition system, and without even you showing your face, I can unlock your phone. So that's what all its machine learning top 10 is all about, right? And it's not just that. Probably Nishant is going to will guide us through each one of them, highlighting their vulnerabilities to emphasize the importance of the deployments. Nishan, can you go to the third slide? Third one. Yep. So this is what the OWASP machine learning top 10 website looks like as of now. You can also head on to mltop10.info, which is our official website, which has all the kind of PDF formats and all those things, right? But Nishant is going to walk us through each one of them and highlight the real world use cases to emphasize the importance of the correct deployment. I think Nishant, you need to stay on the.
Yeah, I just unmuted. Yeah.
Yep. So notably, this work is endorsed by esteemed bodies such as NSA, which is National Security Agency by US, ACSC, the Australian government, and the European Union, when they were when they were influencing or formulating their AI security bill. They used this as a reference to draft their first bill. I think Europe did their AI bill in February 2024. So that's where they referred this project. So brief introduction about our project leaders. So presently we have three active leaders representing diverse regions and expertise. Myself from India, Shan, who is a tech enthusiast, he's from Australia, and the seasoned AI expert Rob from Europe. All of them bring different expertise to the table, and so that we have a wide regional access to the community and the reach. So that's where we have leaders from all the three continents. So, however, our project has a wide array of active contributors, including Nishant, who joined us during the project when it was at very nascent stage. Without further ado, I'll pass on the baton to Nishant to lead us forward and walk us through the demos and what each top 10 looks like. Over to you, Nishant.
Yeah. Hi, team. Hi, everyone. Uh, so let me start with the machine learning introduction. So machine learning, as we all know, is a growing topic and is spoken a lot in the social era. So it all began with a dream and with the movies where a lot of machine learning ways where the machines are thinking, machines are able to make their own actions, and lots of innovation and ideas and dreams came together, which drove us closer to what machine learning is actually real today. So machine learning can be simplified as a small uh, set of neurons or perceptrons, where perceptrons are just weighted analogies, where you give in something and you get some output, and all these outputs somehow make sense. And all this is an effort to simulate the brain and how our brain neurons actually work. And that is how the perceptron name actually came up. So machine learning as a whole can be is talked as a singular topic, but it is actually a classification of three different topics: deep learning, machine learning, and artificial intelligence. Machine learning is a way of statistical learning to put everything together so that it makes a perceptron work. And deep learning is trying to add more layers, and without any causal or any explainability, we just try to make sure that it works without understanding the uh, weights and the meaning for a particular layer. So machine learning is the base, and an extrapolation of that is what is deep learning. And when machine learning is applied to a machine, or like let's say an AI or like a robot, and we try to give it some intelligence. Let's say the AlphaGo, which like around 8 years ago when the first AlphaGo was released by Google, that was the first incidence of an AI machine trying to beat a individual human being at a Go machine. So artificial intelligence can be of different mixture of expertise, and it is actually very well covered in the AI robot movie when uh, Will Smith asks a robot like, "Can you write a symphony, or can you make a masterpiece, or like, can you make a drawing like an artist and all?" And then a robot simply asks the human back like, "Can you do that?" So it all comes down to one thing, that no one is one better at everything. It's like we have a mixture of expertise, and mixture of expertise is what is leading the machine learning today. So now we have seen that there are different classes of machine learning and different spaces of machine learning, which can be grouped differently. Now, this is just a simulation of what machine learning actually looks on the behind. And when we talk about layers and when we talk about perceptrons and lot of nodes inside the machine learning models, it's just that some weights click together and then they form a classifier. And here it's just a small demonstration how the classifier is classifying a 2. It's like some weights which represent the features for two, the curves and the dash, and somehow it all makes sense. And this is another GIF where we are generating the images from a set of images. So here it is a 28 cross 28 MNIST data set, which we are trying to generate. And here you can see that it is a 3-level perceptron. And this is also similarly an activated function which is used to generate some images. Now, all these images are constructed using different machine learning algorithms. And all these algorithms go to a different place. Like robotics use a set of algorithms. NLP, the natural language processing, uses a set of algorithms. Let's say stock trading, that uses a LSTM type of models. So each individual area uses a different individual type of algorithm which are better fit to that. Now that we have a general idea like what is machine learning and what are the classes of machine learning, and we now know that there are different algorithms and some algorithms are better suited to a better environment. But all these algorithms can be grouped together on a higher level into 3 categories. So you might have heard about IKEA, or like when we go a furniture and then we get a small set of kit and a manual. Like you can put the hammer here, you can use the screws here like this. So that is what is supervised learning. Someone tells you with a handout, with a blueprint, that this is how it should be assembled and this is how it should be done. So when you know all the outcomes beforehand, that is supervised. When it is unsupervised, it is just that you ordered a product table online and the manual is missing, and you just try to make it to construct and work so that it looks like a table. At first, maybe you start with a 2-legged table, a 3-legged table, or maybe somehow you miss the frames, and then you try to somehow fit in together because you have a mental idea what a table looks like. And without the blueprint, we are trying to construct a table. So that is what unsupervised is. And reinforcement learning. So what is reinforcement learning? It is like giving a chocolate to a kid when he does gets a good mark or he does a good thing, something like that. So it is like you reinforce the person or you give a feedback that whatever you are doing is correct or whatever you are doing is wrong. Let's say we are trying to fill out a maze. So whenever you hit a dead block, we say that, hey, this is not it should be. You get a negative point for doing this. When you get out of maze, you say that, oh, okay, yeah, that's a good one. So this is what a reinforcement learning is. You reinforce, you give feedback to the machine that this is how it should be done. So now all these algorithms, whatever we have, GAN, LSTM, BERT model for NLP, Monte Carlo for sampling algorithms, PCA for high dimensional data, all these algorithms, now we can classify into all these 3 categories. Now that we know that machine learning has 3 categories and it can be applied to 3 different areas of machine learning like AI, robotics, deep learning, and stuff like that. Let's see how this is actually applied to ML ops. Like that is where the work is around. Like when we go and do a applied machine learning work, this is where the pipeline and all these steps of how we actually apply a machine learning model and how we use it as a solution in our day-to-day life comes into effect. So ML ops has 4 major steps. One is data collection and extraction. Second is model training, and next is model evaluation, and fourth is model deployment. So data extraction, why is that a very big step? And why is it labeled as a separate entity itself? So data extraction can be for different purposes, let's say for banking or for medical learning purposes, for identifying a benign or a true cancer. There are, and for identifying MRI scans, there are lots of use cases where you want to extract required data and you also want to obfuscate or you want to black mark or redact the names of the patients. Like there are some confidential informations that can be present in the reports that you don't want to put. So data extraction plays a major part. Let's say it is a traffic analysis. You have to do a data extraction and then classify what are all the different types of packets, like HTTP packets are there, SSL packets are there, SIP packets are there. So the data extraction plays a different and a major role in all the major areas of application, be it medical or be it network or be it robotics. And data, once you have the data in the hand, we have to go for model training. Model training will require the application of machine learning algorithms, and here we split the data into some parts we will use for model training, and we have to ensure that we use all the required data. Let's say there are 10 different categories, then we have to supply all 10 categories in equal weights so that the model does not get aligned to one particular category, no favorism, and to avoid biases. The model training itself has a different category together and an importance, because you have to split the data which you have extracted into a proper training set and a proper algorithm and a proper convergence rate so that the model training can be completed in a good time and it has a good learning curve and a small error rate. Once you have the model, we have to test the model whether how it works in the real life scenario. And how do we evaluate that? A part of the data extracted, let's say 80% is used for model training and 20% is used for model evaluation. So the model is evaluated on the rest of the 20% of data that is collected. And we try to see for F1 scores or basic error normalization scores. And we try to do the model evaluation based on the application that we are doing. Let's say if it is a Tesla model car that we are doing an evaluation, it will have different metrics. So the metrics is going to differ, and that is an important phase in the ML ops. So after model evaluation, we have to deploy the models. And model deployment is a very huge, important, and the final leg of the ML ops. Because once you deploy a very proprietary ML model, we have to make sure that nobody is able to copy it, nobody is able to break into it, nobody is able to copy your weights and algorithms and all the model weights. And we have to, and the inferencing should also be done at a very good speed. So model deployment plays a huge factor. Now, ML ops can be done in a manual cycle where the 4 basic cycles of extraction, training, evaluation, and deployment, they can have different stages when it is split into manual or automated pipeline. But that is another problem together. Now, we have gained the idea of what OWASP is, what machine learning is, what are the types of machine learning algorithms, and how is MLOps all fitting everything together. Like MLOps is basically application of all these algorithms together for a particular area. Now, the main focus is the ML top 10. What does it mean? So when we go for MLOps or like a ML pipeline, there are certain risk factors and vulnerabilities that we have to address to make sure our ML model and the ML pipeline is secure and confidential and remains proprietary. So there are some items that we are going to discuss, and these are just the top 10 factors that we are going to discuss here today. So first is input manipulation attack. So most all these attacks are simple enough that it can be identified by the name itself. So input manipulation, what does it mean? Based on the input that you are giving to the model, it can affect the output. Here we have a case where, like, let's say it is a case of autonomous vehicle, like a Tesla or a Mahindra with an ADAS system. Here we have a stop sign. So when this stop sign, the machine or like the model in the car reads it, it is able to identify with the object detection and a CV model that it is a stop sign. But let's say there is a malicious user or like there is a malicious entity that is roaming around and he wants to do some malicious activity or like a terrorist activity here. And he adds some small amount of noise. This is a small amount of noise that is pixelated data, which is visualized here. And when this is visualized, pixelated data is added to this particular stop sign, which looks perfectly normal, we get something like this. Of course, to the naked eye, the third image and the first image, it looks a little bit different, but overall, we don't see any major differences, right? But when a perfectly normal object, an ML classifier, looks at this particular stop sign, it will say, oh, the speed limit is 120 kilometer per hour. So it will go and increase the speed limit, where you can see that the roads are narrow and it is also at a crossroad. So this speed limit is not advised. So we have a working demo over here where it talks about the algorithms that are used to do the perturbations. So these perturbations are at a very minute scale, such that the naked eye is not able to identify it, but it is able to misclassify the object model in the car. So there are various Werner algorithms, and this is a hot research topic also. This is just a basic idea of one use case where it is bad for the consumer. Next is a data poisoning attack. So what happens when a data is malicious, or when the input attack is malicious? When ChatGPT was initially launched, various SQL attacks were named, and they were classified, and they were improved in the next iteration. So basic SQL attacks, which are open for normal web servers, are also applicable for LLMs or other normal object models. So these are another class of entities, or another class of problems, or where we have to look out for. Another is model inversion attack. So one case that we want to discuss here is for bot detection. Bot detection, like 2-3 years ago, it used to be like fill in the captcha, and that will be the process for saying that you are not a bot. Later, if you have noticed, there are jigsaw puzzles that have come up to identify that whether if you are a bot or not. Jigsaw puzzle, as in not click the stop sign, click the car. There are more advanced captchas where you have to actually drag and drop the jigsaw puzzles. And here also we have there are some models which use sophisticated algorithms to detect whether if it is a bot or not. Let's say the number of steps that is used to do the jigsaw puzzle, and the time it used, and the first tile that is used to solve the jigsaw puzzle. All these are inputs to identify as a bot detection or not. So that even if a bot completes the jigsaw puzzle, we are still able to classify it is a bot based on the behavior analysis of how the bot is able to solve the particular captcha. So this is another interesting use case. And and this comes handy when there are this is one particular use case in US where the tickets of Taylor Swift were sold out in a matter of minutes, and a lot of them were available in the black market. So this is one particular scenario, but the bots are everywhere. The fourth type of ML attacks is membership inference attack. There is not much public awareness about it, and there is not much publicly known data on this particular type of membership inference attack. And the basic reason is for confidentiality and to protect the safety of others. Of course, there are inference attacks possible. So let me discuss a use case when, let's say, there is a banking, when we have a bank, and the bank has a few thousand customers, and we are able to identify one particular person to the bank. Let's say bank A has a person X. Once we identify that, we will be able to identify what type of people are investing in that particular bank, and how the bank is dealing with what set of customers. So there are different banks. We also have one foreign bank which does not come under the scrutiny of any foreign governments. So once we identify an individual, the individual data and the bank data are prone to attacks. So the fifth is model stealing. Let's say we have developed a model which is able to do one item. Let's say it is able to do the stock prediction very good. Or let's say we have deployed a autonomous vehicle which is able to drive from point A to point B in an Indian road. But these models can also be inferred and it can be replicated and the weights can be taken away. So one research paper was where the BERT model, which is used for NLP, that was the NLP model was cloned by an attacker imitation. So similarly, there are other use cases. Let's say for stock, we have a Tesla model car ML model. These all needs to be protected in certain way that the models are proprietary to the company itself. So next is AI supply chain attacks. So we in machine learning use a lot of packages. Let's say NumPy, scikit-learn. All these packages we use for our or PyTorch or tensors. We use to make sure make our work to reduce our work and to use inbuilt functions. And these inbuilt packages might have some attack vectors that are unknown to us. This is one research where we found out that MLflow is a MLOps pipeline that is available. In the MLflow, it was able to infect the SSH keys for private keys so that the SSH was possible using the MLflow. So if an individual has installed MLflow in a particular fashion, then RC was possible on that particular machine. The seventh type of attack is transfer learning attack. So here, I think a couple of weeks ago, there was a famous vulnerability of the libxz, where we had a backdoor and it was affecting a lot of public packages. There, a backdoor was available. And it was found out immediately just because the Microsoft person was lucky enough to identify the 50 millisecond of delay. Similarly, backdoors might exist in a public packages for malicious intents. So these backdoors packages are very hard to track while using inside the ML packages in itself. 8 is model skewing. So model skewing is a little bit complicated, in which one simple example is to be, let's say we have a medical model for cancer, which is a normal basic tumor which can be removed easily, or like let's say it's a very cancerous or a dangerous type of cancer. And here when we do the model training for a very little amount of cancerous danger cancer type, then the model will be skewed and it will start predicting that the non-dangerous type of cancer is also good, or like it should also be removed. So here, these are the ways in which the model can be skewed in a particular way or towards a particular class or a particular category. It can also be skewed for racial identifiers. So model does not know the features on which it is classifying. It is trying to reduce the error on the training data. So let's say even if the training data is between two different genders, then and the gender is skewed in one particular side, then the model will overfit on that particular type of training data. So that is one type of model skewing, in which the model will not be able to disidentify from another class because it overfitted into one particular category. 9 is output integrity attack. So here, let's talk with an example where we have an input classifier for a dog and a cat. And it takes the hidden layer here demonstrates the features that are abstracted for dog. But let's say if there is a misclassification, instead of dog, it is classifying as a cat for every iteration. Then it is a misclassification. This is a very small use case. this classifier, let's go back and visit the first example of Tesla car when it was a stop sign and it still identified it as a 120 kilometer per hour speed limit sign. So the case of classifiers is a very important role because it is used in a lot of areas, and this output integrity attack can heavily impact these regions. Even in the case of cancer research, let's say we are categorizing the particular tumor medical report as cancerous or not. If it is a misclassification, then the patient's life is at a very big jeopardy. A simple how this can be a classification attack can be constructed. Let's say in the left image we have a particularly good apple, and then in the right side just a white paper with iPod is written, and that heavily skews the model in favor of iPod. And it does not, there is no mention of Apple here itself. So these are some ways in which the classifier itself can get confused easily, which should be of top priority when building a ML model. Next is model poisoning. So this is the last type of attack vector that we are going to see today. So here it is a case of spam mails. So let's say we train on a particular set of keywords which say that it is spams. Let's say hurry, hurry, offer ending soon. These are some sort of very clickbait and spam type of emails. So once the model is trained for these type of keywords, we all have Google Gmail, right? So in that, it automatically classifies some of the emails as spam and it adds a label. So what happens if the keyword is mismatched or like it is removed from a spam training data? All the clickbait items will also get classified into important type of email or a normal email where the user will be prompted, oh, this is from HDFC Bank. Okay, they are requiring my password. So so the end user will be vulnerable, and that is why it is also important to make sure that the model is susceptible to model poisoning type of attacks. Just a second.
Hello. Hello.
Yeah. Hi. Sorry. Yeah. So there is another set of items that we want to show as which does not fit into this particular set of items. So here, a person is wearing a particular image on his T-shirt, and that makes the object not detected as a person or as a human being. So once he reverts the image or flips the image to another side, the object is able to, hey, there's a new person over here, right? So the image distorts the person's view of a classifier. So this is a particular type of attack where, let's say, if we have a CCTV camera installed on our home or in a museum or in a bank vault, the particular image is able to make a person invisible to the CCTV's camera's detection. So this is so you will not believe it. This is a paper from 5 years ago. And there are more recent studies where a particular type of T-shirt, here maybe if I can zoom in, so you can see that the particular T-shirt makes a person invisible. It is not an invisibility cloak like a Harry Potter, you might not need it. It's just an image on a sticker that with a T-shirt, which will make you invisible, a type of superhero to the CCTV camera eyes. So so the takeaway is there are lots of ways in which ML models can be susceptible and can be deliberated into thinking that they are safe, but they are not. So this is where the research is, and this is where our OWASP ML top 10 is. And this top 10 only talks about the top 10 types of attacks that are possible. There can be many more, but these are the top 10 that we should always keep a lookout. And you are always welcome for contributions to OWASP ML Top 10. It is an open source item, and so this is one thing that I wanted to share. If you look inside the machine learning, it looks very fancy and good, but it has math, it has linear algebra, it has calculus. Yes, there are a lot of nitty gritty items, but it's not required that you know all the items. Yeah, it is also possible to do research without going into all the mathematics behind it. There are different ways in which you can collaborate. You can talk. You can. Uh, it's not just constructing different types of algorithms where you can collaborate for or you can contribute towards these type of ML top 10 attacks. There are other ways also. So yes, thank you. Maybe Q&A if you guys have.
Hello.
Yes.
Yes, our co-host wanted to talk something. Sagar, your voice is not getting. We are not getting your voice. Hello.
Oh yes.
Yes.
Yeah, is it
Sagar.
audible
Hello.
now?
Yes. You are yes audible. You are audible.
Yeah, so Nishant, if you can go to the
Your voice is
website and
breaking little. Yeah.
okay.
Yes, Sagar. Sagar, are you there?
Hello.
Hello.
Yes, you are audible
Yes,
now,
you are
Sagar.
Okay,
audible.
now I'm audible. No? So if you click on ML01, yeah, so this is the way, like the risk factors, what is the example scenarios for all the top 10, and how do we categorize the detectability, the technical difficulties of all those attack vectors, and which is the first one to look out when a machine learning deployment is getting to production. So this is how we categorize uh, ML01 versus ML02 and so on. Yep. So that's all I wanted to add.
If you guys
Okay.
have any other
You can
questions
start.
related.
I think you can stop sharing, Nishant. Then I think.
Yes, yes, yes.
Okay. So if anyone have any questions, you can ask them directly. We have a 10 minutes of Q&A session.
Hello, am I audible to you guys?
Yes.
Well, hi, I am Gaurav. Right now, I am in first year. What I want to ask is, I am totally new in this field and I want to learn machine learning from scratch. So, how should I start? And sources. I'm asking particularly about sources. There are many sources, but I'm too confused. What should I follow and what not?
So there is a very good Andrew NG course available for machine learning. It is available on YouTube also. Maybe you can start from there.
Sure, thank you.
Do we have any other questions?
Hello.
Yes.
Yes. Is there anyone have any question? Okay, so I think no one has any questions. Okay.
Hello, hello.
Yes, you are.
Yes.
So, Saga, I personally want to ask you something.
Mm-hmm. I mean, personally,
Uh,
if you want to ask me out of the call, outside of the call.
no, 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 not like that. It's like how I want to know about your journey, how you started and all,
Okay,
your
so
experiences in in this field.
yeah, so I have learned with projects, and as Nishant rightly mentioned, with few courses like entry NG and a lot of open courses. I don't feel that you need to pay to learn if you have to go for Coursera's and all. But start doing projects, start looking around for collaborations and in the field that they are doing. Start doing projects, as simple as that. So you will learn, you will stumble upon problems, and then while fixing those problems, let's say, how do you install TensorFlow, how do you install PyTorch, Keras, you start from that place. And then when you familiarize with one of those machine learning libraries, whichever best suits you, let it be Keras, PyTorch, or TensorFlow, and then when you choose one, and then you go along building a machine learning model, find out what best use cases for you, whether you want to work on image based machine learning models or textual based machine learning models, and then you narrow down to what your interest lies in. So read a lot of articles, read a lot of books, watch videos, and I think that's all. That will be overwhelming for you if you do it rightly.
Yeah, sure. It's very.
I hope I answer you correctly, right?
Yeah, yeah, yeah.
Okay.
Thank you.
Yes. Yes, I have a question for Mishant actually, as he has worked at FI India, right? So I wanted to know his journey at FI.
Uh, yeah, so I joined here as a developer, and I
Yes.
started with DNS team here, and yeah, I have been with working on DNS for quite a lot, like 3 years around. And then I moved into traffic classification, where I'll be able to use machine learning algorithms to better classify and uh, identify malicious or unintended traffics and user profiling, that sort of stuff. So yeah.
Okay. So actually, I wanted to ask you that you have two registered US patents. Can you tell something about that?
Okay, so both of them are in networking domains. The second one is probably more interesting in DNS. So I worked with Nishant in my first team, and then I've hopped on to teams currently working into security development products like WAF. So the second uh, is based on an RFC. RFC, if you don't know, it's like request for features, and when you have a new uh, feature development, right? So okay, so let me get this with a use case. So whenever what you watch YouTube, or let's say watch any shoes on Amazon, you are thrown targeted ads, right? Let's say if you watch shoes on Amazon for 5 minutes, on Facebook and Instagram you'll start seeing shoes. So that's how your DNS data, or aka domain name system, your data is being sold for your to by your ISPs. ISPs as an internet service provider. Let it be. I don't know what you guys use. Hathway is there in Pune, I guess. Other than that, let's say Airtel. So that so using that, your DNS data is sold. Now, what the DNS privacy has done in recent last 1 or 2 years is so DNS is plain text, as in UDP or a TCP base, not even TCP these days. It's mostly 70% of DNS traffic is UDP based, so that everyone can in the middle can see what DNS transactions you are doing. Now with DNS or HTTPS, so HTTPS is SSL'd in the sense that no one in the middle can know it. So, but it's slow because it's doing encryption between client and server. With ODOH, which is more recent technology, I think when you go on the settings of your Brave or Chrome browser, you can enable DNS privacy. Probably you can go ahead right there and check. With that, no one will know what you're watching on YouTube or Amazon or Flipkart. But it comes with a setback that there are parental control features, like say that your kid does not should have access to YouTube between 8 to 9 p.m. or it should not have access to for the obvious websites. So using parental control, the Airtel guys or the Geo guys or the Hathway guys, they basically restrict the client or your kid to go from the website. Now, since the client is the only owner or your kid is the only owner of the data, the server cannot, give that feature right now. So with the patent which we did, it brings back that feature up of that parental control since uh,
Okay.
since it's a huge market out there.
So thank you, Sagar. Okay. So I start the behalf of the entire community. I would like to extend and grateful of you for your valuable contribution for today's live session. Your insights, expertise, and engaging presentations have enriched the subject matter and left lasting impact on our community members. We truly appreciate the time and efforts you have dedicated to sharing your knowledge and experience with us. Thank you once again. And um, okay, and just a second. Guys, here is a feedback form, and you just have to fill a small of the mail mentioned in the feedback form. The session certificate will be shared on the same day. So you just have to submit the small feedback form that will be available for us and the session speakers. So thank you guys for today's your time.